take the example with VIPKeylogger focused in adding additional detections for this specific malware family. We see here the VMRay analysis report. That's basically behavior that we observed during the execution of a file that we're going to record here, and then basically present here in a report for very easy and quick understanding what is going on here. We see, well, at the first place here, it's quite obvious. It's a malicious sample here. We have the classification as spyware. We know it's keylogger, it's a stealer. It's probably collecting data and exfiltrating them. And we have the threat name here, which is VIPKeylogger. There are some additional variants here, likely coming from external services like reputation or AV detections. And if I'm not mistaken, I believe VIPKeylogger is also called, or there's a similar word for that, which is not found keylogger. But usually it's well known as VIPKeylogger. Yes, and taking a look here into the VMRay threat identifiers that Archie already covered before, it's just a information and a score on specific behavior that we can observe during the execution of the specific malware in a safe environment. We can see here, we have plenty of them triggering, and I will just cover them in a second. If you go a bit further down here, we see some malware configuration being extracted, even some screenshots to see what is going on. We see process graphs to have a very quick and basic understanding, the MITRE mapping here, of course, and finally some meta information. All of these details, this is just the high level. We can, of course, go deeper here as well, but all of those details in this case are being extracted in just 5 minutes. Well, 5 minutes is not the default value here. So usually we capture everything in the default analysis timeout of 2 minutes. But of course, that depends a bit. Usually everything that you want to have is there in 2 minutes. But if you want to go deeper into an analysis report, if you maybe want to observe if there's something else that is coming at a later point of execution, you can just increase this analysis timeout during the submission how you want to. And in this case, we've just selected 5 minutes because we want to do a bit of a deep dive into this family here. When looking here into these monitored processes, usually you probably would expect you see a sample start and then you see some process being executed. We even have some memory or some process injection here, and that's basically it, right? But in this case, it's even more interesting because we somehow also see another part of this graph here that indicates a reboot has happened, right? Well, reboots are not really usual for malware, I would say, right? So malware usually doesn't really trigger a reboot on the system, but we do it with a specific reason. If malware tries to get or to establish persistence on an infected machine, which means that whenever it should survive reboots, if like the user is going to home in the evening, he's shutting down the machine, starting at this machine on the next day, then of course a threat actor still wants to have access to this machine. And that's why they usually try to get persistence. In this case, there is a remark message here at the top of the analysis report that indicates an automatic reboot has triggered due to the sample installing startup script or a task for an application for persistence. And I believe this is very important and relevant. And if you want to look deeper into that, you can even go to this VTI section here. There's this persistence VTI. Then we can see that the process number 2 attempted to add, well, something that seems to be a Visual Basic script to the Windows startup folder, meaning whenever the system gets rebooted, this script is going to be executed. And then, of course, you usually see pretty much likely the same behavior as we have seen before, right? So threat actor is getting persistence here in that machine. We have talked about Yara signatures before, right? So we have recently, in recent months, introduced a new Yara signature that's supposed to detect the VIPKeylogger payload. In this case, in its already unpacked plain format when it's being executed in memory, right? So you see here, it's actually triggering in the memory dump from process number 2 and also from process number 8. Right? So if you look down again here, we see it has been captured already in process number 2 and in process number 8 over here. But you may wonder why not in process number 3, right? Well, that's kind of difficult to explain sometimes, but one of the usual behaviors on why this hasn't been observed here in this process is usually because of the reboot that has been triggered, right? So maybe at the time before the payload has fully been injected, the reboot occurred. But of course, that's the reason why we, at the end of the day, have this reboot to see what is happening afterwards. With having this Yara match, we of course also being able to identify this as VIPKeylogger, which means we also can execute our malware configuration extractor for VIPKeylogger, which means that usually malware comes with embedded details information that usually either enrich some information that is being needed by the malware, or it even can somehow describe a bit of behavior that the malware might do during the execution, right? It can have some specific flags being set, like you do this or do that, right? But the minimum required information usually is the command and control server, which is usually called, also known as an IOC. That's very, very relevant if it comes to TI. And in this case, VMRay config extractor for VIPKeylogger here, if we just go down, extracted this malware configuration that's usually obfuscated and or encrypted. So we are finding this location where this is stored, and of course we are extracting this, we are decrypting all this information, then present it here nicely in the analysis report. But of course we also have this in the analysis archive in a JSON file format, so that it can either be very easily accessed and automatically further processed. Before I quickly want to cover this one here, let's actually go back here to the VTIs, and we have mentioned keylogger is a stealer. So we have a VTI here that's actually raising this core immediately to malicious that indicates data collection. It seems that the sample is trying to read cached credentials or other sensitive data, in this case here of a couple of applications, Google Chrome, Internet Explorer, Edge, so a couple of browsers, and even Microsoft Outlook. And of course, for keylogger, for a stealer, it's usually that this behavior is, should be there, right? And if you go further down here, you can even expand some of those VTIs here, and you see a more detailed description on what is happening, right? So in this case, you can see here a bunch of different browsers going from Google Chrome over, what do we have here? Brave, we have somewhere Internet Explorer, Firefox. So lots of different browsers are being targeted here to just search if they're being installed, and then try to exfiltrate sensitive data of them. Could be credentials, could be cookies, could be maybe even some other information that maybe you can extract from browser extensions and so on. Same thing here. We have for mail data. In this case, Microsoft Outlook is being targeted, and also Thunderbird, just to find if this application is installed, and if yes, extract sensitive information such as usernames, credentials, and so on and so forth. One very interesting highlight, I believe, here is also the usage of direct system calls. We actually spent lots of time in the last year, in 2024, to look into direct system calls and also indirect system calls. And the goal of using this is just to make monitoring-based solutions that are relying on hooking blind, right? So instead of just following the usual Windows API on how you should go from the high user level all the way down to the kernel level, they are just directly making use of system calls in the application itself. So from the application, they are directly going to jump into the kernel and then trying to execute those functions. That just means that whenever there is a hook being installed, either on user level of those APIs, maybe even on the native level, those hooks would be useless because everything is just simply bypassed by using direct system calls. On the other side, if you have a bit of internal knowledge and you understand how that works and how that operates, the detection of direct system calls is essentially quite easy and not really complex at all. So it can be very easily detected. And it's usually something that you would not expect in a legitimate application. Well, of course, we have plenty of other VTIs triggering here, really describing the behavior that the sample is doing. That really helps you a lot in very quickly getting a good understanding of what is happening here. So before we wrapping this up, I still want to quickly focus on the extracted malware configuration that is very important if it comes to threat intelligence data. So in this case here, we see this is keylogger version 4.4. That's just part of the encrypted config, of the embedded config. There is an encryption key, which is, that's the key here, but we also extract the algorithm. So essentially, if you find this blob of encrypted data inside the binary, that's the keys in the encryption algorithm that you need to decrypt them. Why is it here? Well, we still believe that tracking VIPKeylogger sample or other samples, it's very useful if you have the key, because then you either can select or find maybe samples from similar campaigns or from the same campaign, because they usually make use of the exact same key. Then we see the URL here to a SMTP server, which, as Ertu mentioned before quickly or briefly, is the VIPKeylogger makes use of different ways on how to exfiltrate data. SMTP is one here, as the mail server being specified. Of course, there have to be some credentials inside the sample that the sample is used to when it's connecting to the mail server, that it can authenticate itself. And then, of course, there also have to be a recipient, which means that once this data has been collected and it needs to be exfiltrated, that the sample knows, well, where do I have to send this email to? Basically, that's supposed to be the operator at the end of the day. And in this case, we actually have another command and control server communication channel here, I would call it, which is Telegram. Telegram is a very popular and quite known instant message service that's cloud-based, right? And there's a very interesting observation we had over the past month, actually even years. Instant message services like Telegram or even Discord are getting more and more used. They're getting more and more popular by threat actors for establishing command and control server communication. So we spent a couple of time in thinking on why is that, and there are a couple of good reasons why threat actors might even go with Telegram here in that case. So first of all, well, SMTP is kind of legitimate, it's fine, right? FTP is another option, but not really that legitimate. I believe it's not that common that you maybe see lots of FTP traffic nowadays. But at least for Telegram, this communication is usually very legitimate. Nearly lots of people are having Telegram installed on their phones, so there's lots of traffic to the services, right? And now we have two different options, right? Threat actors could either say, well, let's build our own command and control server infrastructure. So just setting up hosting services somewhere, buying servers, getting IP addresses, running their own software for a command and control server communication. That's one option. But of course, that requires usually credit card. Then you maybe need to have some VPNs or proxies so that you can hide your IP address behind that, right? Otherwise, it might be very easy to track down who is operating that service. If they are going with Telegram, then they usually have way less pain points they have to come through, they have to get through, right? So it's a cloud-based service that is already hosted, right? They don't really have to care at all about hosting. They don't have to build up a server. They don't have to maintain that server. They only need a phone number to be able to register to Telegram, and then essentially they can use it for free, right? And that's, I believe, and pretty good argument to use that. Then they can just create bots there, they can create group chats, and then they can just play around with that. What is essentially also what we see here, then you basically have a bot. This bot requires something like an API token that you can interact with that bot, right? And a chat ID. And what you see here is basically if data is being exfiltrated, or well, maybe just this infected system registers by the operator, then they just need the bot ID, which is the ID, and of course then the token for the bot, and then the chat ID. And what is going on then is that VIPKeylogger is just writing a message to this group chat here and saying, well, I don't know, we haven't looked into how this message format looks like, right? But I'm registering here as an infected host. Here is the data that I have collected, right? So that's a simple way of communication here. But of course, we also have seen in the past that this is being used as a bidirectional communication. So it's not only the bot that can send chats or messages into this chat, but also the operator can send messages into the chat that are regularly being checked by the bots. And then they can read that, they can interpret that, and carry out specific actions the threat actors want to have, right? You can say, well, maybe make a screenshot, send it to me, right? Or just download this additional payload, execute it there. So there's lots of things that can happen. From a threat actors or from a threat researchers, like from our point of view, from a defender's point of view, this is actually valuable information that you can use to track down specific operators. You can find clusters. You can even find maybe operators that are using multiple different malware families. So we just recently looked into one of those Telegram bots here, whereas the bot name was indicating something VIP snake, whatever, right? And there, I believe you also have a bit of relation, what Erto mentioned before, VIPKeylogger, snake keylogger, right? So there's close relation, and maybe threat actors or operators are even using both of them together at the same time, infiltrating different hosts, but just having one Telegram chat where all of them are actually communicating with, right? You could find samples that are being distributed by the same operators based on the ID here, based on the bot token, based on the chat ID. And there's also plenty of other open source intelligence topics and stuff that you can do here, right? It's an API of Telegram. You basically have the token here, so you can also play a bit around and do some tracking on that side. And yeah, that's important information. And due to the malware configuration extractors we have here, it's also very easy then just to track those operations down here and following them to also ensure you can have you have good insights, good visibility, and can protect your environment.